Hello, West Springfield High School geometry students. In this video, we are going to be discussing topic 18A, which is the Pythagorean Theorem and applications of the Pythagorean Theorem. In the diagram that we've got here, I have drawn a triangle, and as you can see, we've got three side lengths here. We've got 10, 5, and x. Now, it is important to note that the missing side length is our hypotenuse. Remember, the hypotenuse is always in a right triangle, the side that is opposite your right angle, which means that x is our hypotenuse. And the reason that that's important to us as far as the Pythagorean theorem goes is because when we are doing the Pythagorean theorem, it doesn't matter which leg we make, A or B, but what does matter, what we always have to make sure that we have right when we are working with the Pythagorean theorem is the hypotenuse. If we do not have the hypotenuse correct, it is going to mess up everything else that we do with the Pythagorean theorem. In this case, our hypotenuse is the side that we don't know, so x is what's going to go into the Pythagorean theorem in place of c, and that's exactly what we've got here. 5 squared plus 10 squared equals x squared. If you simplify what you've got there, you square 5 and you square 10. 5 squared gives us 25. 10 squared gives us 100. And x squared is obviously just going to be x squared. If you add those together, you get 125 equals x squared. And if you take the square root of both sides here, you will end up with x equals the square root of 125, or 5 times the square root of 5 if you were to simplify that as a radical. Okay? Either way of answering this would probably be acceptable unless there were directions or explicit instructions that told you to give your answer as a simplified, as a decimal. And if you were asked to give this as a decimal, 5 times the square root of 5 would actually be 11.18. So any of those ways would be an acceptable way, assuming that there aren't instructions that specify how you need to give it, of giving an answer to what our missing side length would be. Okay? We've got another example over here on the other side where we have drawn another triangle, except in this case, our missing side is one of our legs. Okay? So again, the hypotenuse is going to be the side that is opposite our right angle, and so this is the side that we have to make C, which is going to be 11. Okay, x and 4 can go in place of either A or B, it does not matter. So the way that I've set it up here is I've said that x squared, I've made xa and 4b. So x squared plus 4 squared equals 11 squared. X squared obviously is just going to be x squared. 4 squared gives you 16. 11 squared gives you 121. And we are next going to want to subtract 16 from both sides. And that's going to give us x squared equals the square root of 125. Take the square root of both sides of that, and you get x squared x equals the square root of 105, or x equals 10.25, because there is no way for us to neatly simplify the square root of 105 as a radical. Okay, so you would most likely want to give your answer for a question like this as a decimal, okay, unless there were instructions that said you can leave it like that. Okay? And finally, there is one more application of the Pythagorean theorem that we are going to look at here, where they give us the sides of a rectangle are 2 and 2 times the square root of 3, and they ask us to find the length of the diagonal. So what I have done here to do that is I have drawn a picture of this rectangle so that we can see what it looks like. And in this case, so we've got our side lengths of 2 and 2 times the square root of 3, and they are asking us here to figure out what the length of our diagonal is. Now, in this case, our diagonal would be the side that is opposite our right angle in a triangle, so that our diagonal here is going to be our hypotenuse. which means that when we set up our Pythagorean theorem equation, that is going to be our C term, is x. Okay? I always like to start my Pythagorean theorem problems by writing out the Pythagorean theorem equation. I find that that makes it easier for me. And then I've got to plug in my missing values here. Remember, it doesn't matter which leg is A and which leg is B, but what does matter is that we make the hypotenuse C. Okay, so in this case, our x is going to go in our C spot. So we say 2 squared times 2 times the square root of 3 squared equals x squared. And remember, the two lengths of our legs added together and squared equals squared and added together equals the square of our hypotenuse. Okay, 2 squared gives me 4. 2 times the square root of 3 squared gives me 12. And when I add those together, that is going to give me x squared. Adding those two terms together, I get x squared equals 16. And when I take the square root of both sides to simplify what I've got there, I am left with x equals 4. All right, so these are a couple of examples of applications for the Pythagorean theorem and things that you all will likely be asked to do during your work in geometry and perhaps even beyond. Okay, we've got one more video on the Pythagorean theorem, which is on topic 18b, and in that video we are going to be discussing the converse of the Pythagorean theorem.